Thanks very much. Hello, everyone. It's great to be here at the Funkhouse. I work on a project called Wireline, and our mission is to help open source and independent software developers build distributed and peer-to-peer applications that not only protect end-user privacy and data, but also deliver user experiences that are actually better than the current web and centralized alternatives. And we think this is critical in general for the decentralized community, that we have better user experiences in order to get mainstream adoption. Now, in a few minutes, I'm going to show our new peer-to-peer platform and show how straightforward it is to build applications from scratch. We'll build one here today. But first, I want to just take a few minutes to talk about why we think this is important. And it's on, OK. So we all know there's something broken. Just a small number of companies dominate the web, and they receive an unfair economic advantage from what was supposed to be a public good. Now, it's not just an issue of anti-competitive behavior or data privacy. There's some real dangers here, with censorship, deplatforming, and the possibility of political manipulation. These are no longer just abstract concepts. And some of these companies are so large and so powerful, they're practically immune to any form of regulation. So is the closing in of the internet inevitable, or is there something that we could do about it? I don't know how many people know what the computer is here. It's probably about 6 people, less than that, 6 people in Berlin. So this is how the personal computer revolution started. This is back in the early 80s. This is actually my first computer. It's an 8-bit Sinclair ZX Spectrum. It had 16K of RAM, external tape drive, and if you were lucky, a 12-baud modem. And so out of necessity, this is the first decentralized platform. And there's a lot of similarities from the early 80s from where we are today. On the one hand, fairly simple single-player applications, but on the other, a very vibrant hacker-developer community and a very rapid pace of innovation. So this gives me optimism that we can change the things that we need to change in order to get the internet back. There are even companies like this one fighting against the monopolies of the day. This is the storyboard from Apple's 1984 Super Bowl ad. And you can see the heroic figure here fighting Big Brother, which I think was supposed to be IBM, which seems just utterly ridiculous today. But I bring this up because the market cap of Apple at this point was smaller than some of the decentralized and crypto projects that we know very well. So we have the resources to make changes if that's what we want to do. This is from Chris Dixon's excellent blog where he makes the case for decentralized technologies. In order to become a unicorn, you need to grow as quickly as possible so that you can dominate the market that you operate in. And there's a point in the growth curve where you change from what economists call from being an innovator to a rent seeker. You have to monetize either your user base, in many cases by selling the data or using it for other means, or you have to extract a rent from the developers on your platform. So you initially lure developers in to help you build the platform to bring in additional users. But as the platform matures, you put restrictions on the developers for the kinds of things, the kinds of apps that they can build, in case those are things that you want to monetize yourself. And the network effects here are huge for platforms. So once you become a dominant player, it's very difficult to be unseated. And that leads to incredible valuations that are completely disconnected from the underlying value of the services being provided. And so once that happens, we have these extreme forms of disconnect between the values of the platform and the people that they serve. A result of this is there's been a glut of money coming into the software industry, and that's fueled an explosion in the number of companies and applications that we see. The problem here is that most of these applications are silos, and the businesses themselves are locked in battle with each other and sometimes with their users. Now, it's a winner-take-all world. And so another problem here is that for many of these companies who can't make it as the dominant player, their business model becomes to get acquired themselves, and that obviously leads to further centralization. Now, from a user experience, rather than having hundreds of apps that we have to juggle on our phones and computers, I think we want something like this. Seamlessly integrated, intelligent software that works for us, doing useful things without compromising our data and our privacy. And this is a possible world we could work together to create. This is what the future looked like 50 years ago, and it didn't end well. And this is what the future's looking like today. And so I think we're at a crossroads where we have to choose what kind of future that we want to build and decide to build that together. There's been a growing awareness over the last 12 months, even since the Web3 conference of last year, of some of these problems. And many of us here today are working on decentralized technologies that I think are going to make a profound difference. But there's a danger that that won't be enough. I think we have to solve two fundamental problems. The first is we need to create better economic outcomes for independent software developers so that they have the resources to create the innovation that we need in order to change the system. And the second is we need better user experiences, otherwise we're never going to see mainstream adoption for decentralized technologies. And so at Wireline, we've been working on some of these problems. We're working towards creating a new ecosystem for independent developers so that we can actually change the rules of the game. And what I'd like to do now is just show a very small part of that with our new peer-to-peer platform. I'm going to demonstrate how we can build an application using that. Creating apps is difficult. And Juan said this really well a few minutes ago. So creating apps is difficult. Creating decentralized apps is really difficult. Creating peer-to-peer apps is even more difficult because you have less control over the network. In particular, you can't depend on any back-end infrastructure or cloud technology or any of the web frameworks that you would usually use to build applications. So we're going to show now some applications that we've built and then show how our SDK works. In fact, the first application, I've been presenting these slides from a Prezzo app that we built on the Wireline platform. Now, all applications on Wireline will work without any back-end or centralized components whatsoever. They also work offline. In fact, in a peer-to-peer network, offline really doesn't mean anything at all. So this app, Launchpad, shows a list of all of the public apps that have been registered with the Wireline naming service, which is a permissionless blockchain. And any developer can freely create apps and publish them to the blockchain without any restrictions or any interference from any other organization, including Wireline. So I can show you some of the apps that we've built. We've got a calendar app. These are real working applications that are peer-to-peer. We've got a simple spreadsheet. We've got a Kanban. We've got the presentation that I mentioned. We've even got a simple map application here that we're working with Mapio project to ultimately enable the tiles themselves, the data to be loaded from the peer-to-peer network. Now, one of the hardest things in building decentralized applications is collaboration. And all web apps use centralized databases currently in order to solve this problem. In the Wireline framework, we have lightweight shared collaborative spaces that we call parties. And parties solve some of the really inherently difficult problems associated with peer-to-peer or any other application. So data replication, consistency, encryption, and access control. And so I'm going to demonstrate how this works now by inviting my colleagues to this current party. I've got a document I've got open here. I'm going to create a link, and I'm going to just use this tool here to share the link. And they should be able to join the peer-to-peer network. Now, I'm just going to demonstrate here that we're actually completely offline. So if I say, hello, Google, we'll see that the browser's responding. We're not online here at all. We're connected to the same access point, but that access point's not connected to the internet. And so if I go back to Launchpad, I can see I've got 3 peers that have connected to my swarm. If I go to the members panel here, I can see Chris, Max, and Solar have all joined the party. And they should be, if I open up the panel here, I can see that they've all joined here. and they're busy typing away. If I close this is the debug panel. It shows the actual network topology, and we can see their cursors moving as they start typing. So again, we're not connected to the internet. We're just swarming on the local peer-to-peer network, and the data is being replicated automatically. Now, we've seen this kind of thing before 10 years ago with Google Wave and Google Docs. It used a technology called operational transformations that enabled this kind of real-time collaboration. But that required centralized infrastructure. What we're doing is extending a range of technologies called conflict-resistant replicated data types, that's a tongue twister, CRDTs, that enable this kind of real-time collaboration, but in a peer-to-peer setting. And since these applications are no longer silos, we can do other interesting things. So for example, we can embed applications built by different developers inside this document, or we can do all other kinds of integrations as well. So for example, I can include our tour map here in this application. And this is still a collaborative app. You see if I put in some numbers here and I go to the actual application, it's updated as well. So each of these applications were developed by different teams that are now able to be brought together in this other app, which is just a shell app launchpad that anybody else could build and replace. Okay, so we've been working with different teams to show what can be done with the platform. Next, I'm going to create an application from scratch and show you how easy it is to do that. So I'm going to use the Wireline CLI, and I'm going to use a command here. I'm going to wirepad create. So that the wire is the Wireline CLI. I'm going to fork an existing React application, and I'm referencing a GitHub repo that has that. And we'll go into that subdirectory. Now I've cached, this is the Node API, I've cached some of the Node components to speed up the demo. So I'm going to open up the code here. Can everybody see that? Can anybody see that? Okay. You'll see there's just a simple definitions file and a React component. And what I'm going to do, first of all, is I'm going to register this pad with the Wireline naming service, so wirepad register. So that's now registering the metadata with the blockchain. And now I'm going to say yarn build, and build that in the background. Now, we're running Launchpad here in development mode. And so it should just pick up the changes here. I'm going to refresh, because sometimes that takes a second. So if I refresh now, I should see the Tasks app, which is the app I'm forking in the top left-hand corner. And now if I click on that, I'm actually creating a tasks list. So we'll call that Web3. And I can say, I can create my own list, and I did that this morning. Now, from really easy start, we've got an application running, and because this is running within the context of the same collaborative party, Max, actually, Max, you're not connected to this party. So I'll invite you again. I'm going to invite Max here to join. Can you get him? While Max is doing that, let's change this pad and do something a little bit more interesting. So the first thing I'm going to do is go and change some of the definitions. So we're going to build a chess app. So I'm going to change the pad to chess. I'm going to change the icon, and let's change the color just for fun. And then there's a field here called view. This identifies a particular subset of data within the party. You can think of it roughly analogous to a database table. So I'm going to call that chess. And then the pad, first thing I'm going to do is change the render function. So I'm going to render using a popular Node component called chessboard JSX. So I need to import that now. And I'm going to do a few other things here. We don't need these methods anymore, so I can remove those. And now I'm going to just save the pad and the defs and see if that causes the app to get updated. So you see Launchpad is reloading now, and the chess app is there. So if I click on chess now, let's call that game, should have, now I know what I've done here. I've not set the initial state of the React control, so I'm going to set game to new chess, and that should be enough. And reload here, and now I've got my chessboard. Okay, so this is plain React. There's nothing really special here. I can move the pieces. But if I refresh the board, because I haven't saved any of the pieces anywhere, obviously the state is going to get lost. So the next thing I'm going to do is create a little handler here in the chessboard. So add the onDrop param, add a function to handle that. Wrong thing here. Okay, so I'm getting the from and to square from the React control. That's pretty straightforward. I'm using the game class, the game module, to validate that that's a good move. And then if it is, I'm going to create a protocol buffer object, just as a JSON object here, and I'm going to append that to the view that I named earlier. Now, the way the view gets injected into the React control is using this with log view higher order component. This is a standard React idiom for injecting properties, and we're injecting this data view from the party into this control. So now I've included that mutation. Now I need to process the mutations whenever there's a mutation on the network, and I can simply do that by creating a new state object, iterating through the mutations, updating the state, and then setting that as the React control state. So if I save this now and wait for the app to update, now if I make a move, this time's just me moving the pieces, and I refresh, now the game state has been saved to the party. Okay, well, let's take this a little bit further now. If I go into the chat application here that here it is. Hey Max, let's play chess. Now, this chat application was built by a different developer team, but when I click hash here with the complete, that's doing a registry lookup to the Wireline naming service, finding another pad, and now if I click on that, I didn't press enter. If I click on that now and I click on the link, we're both in the same party, so we can both access that. And if I make a move here, I should see, with a bit of luck, no, okay, well, that's okay. Because sometimes when you're playing against humans, not everything works. So what I'm going to do instead is I'm going to build a bot. I'm going to build an AI, a super intelligent AI, to play against me. And I'll do that just using the Wireline SDK again. So I'm going to say wire, and this time wire bots create. Again, forking an existing GitHub repo that's a template for building bots. Now, I should tell you what a bot is. Of course, not all apps are just front-end components. You need to do back-end processing, number crunching, asynchronous back-end processing. And we call this a bot. A bot is a simple Lambda function that can run anywhere on the peer-to-peer network and interact with the party just like a human participant. So we're going to build a bot here. CD, and I'm going to call it the chess bot, and open up the code here. And there are just 3 files for the simple bot. There's a definitions file, the Lambda function itself, and the definition. So if we go into the config file here, I'm going to call this chessbot, and I'm going to call it chessbot. Whoa. In the defs, I'm going to change the view name to reference the same view that we defined in the chess pad. So that was chess. And that enables the pad and the bot to communicate together. And then in the Lambda function, I'm going to just do something really simple here. I'm going to use the same library that I used in the pad. That's the chess library here. And all I'm going to do, again, is very similar to what we did with the pad. I'm going to process the mutations from the view that's injected and create a new chess game state. So if I save all of that now, and I go to the console, just like, if I remember my key shortcuts, oh, I remapped it earlier. That was too difficult. Okay, so the first thing I'm going to do is wire bot register. And just like the pad, this is going to register the bot with the Wireline naming service. And so that worked. And then wire bot run is going to deploy that bot in debug mode on this local machine here. But in production, I could deploy that to anywhere on the peer-to-peer network. I could deploy it to a trusted cloud container if I wanted to do that, or I could run it on my own infrastructure wherever I want to. So I retain full control over the bot. Now, as bots are just nodes on the peer-to-peer network, what I can do here is click on this and search the Wireline naming service, and I don't see it. Let's see, what are we doing wrong here? What would normally happen is that the bot would show up here. So I'm just going to check that we're actually working on the same network here. Yeah, that's fine. And then if I click here, yep, let's try that one more time. Wire bot run. And well, let's try wire bot register first of all. The block time, I think, is about 5 seconds on this test net. So let's see if that worked. And wirebot query. So now I'm just going to run a GraphQL query against a full node blockchain node here. And I see that it is registered. And now wirebot run. Now my bot is running. And if I click here now, okay. Should we call that Apollo caching? It's Apollo caching bug. So now I can select the chess bot from the registry, and in a moment it'll join the party, just like I can see that, right, so it's now joined along with Max, and in the debug panel I can see that there are 3 nodes now in the swarm. And it's logged the current state of this chess game. So if I move the pieces now, you should see the ASCII ASCII view get updated. That's so strange. Well, we've got some latency going on here. So while we're waiting for it to catch up, I'm going to try one thing here. We're going to create this super AI to play chess against. So we'll see if that gets restarted. Here, all I'm going to do is get a list of the valid moves for this particular chess state, pick one at random, and then append that to the feed. So the bot has restarted. I'm going to create a new game. And let's see if we're lucky here. I'm going to refresh just in case that changes anything. And look at the debug panel. Well, we see that the bot has connected, but let's see if this actually works. I make a move. It works. Fantastic. Okay. So the chess bot is now swarming on the same network, getting mutations whenever my peer publishes a new record to the peer-to-peer network, responding to that simple Lambda function, and then taking an action and posting that back to the feed. And so we can see how all of this comes together. So obviously this is a very simple, straightforward example. But you can do with bots all of the things that you would traditionally do with cloud infrastructure running in the background. But they run as full peers on the peer-to-peer network, so you can control where and when they run. Okay, I'm going to go back. Let's go back to the presentation here and just finish up. A key insight that we had is that we can build apps from front-end and back-end components that can completely run on a peer-to-peer network without any decentralized infrastructure whatsoever. However, there are still coordination problems that we need to solve, like registration of assets, the pads and the bots and the protocol buffer types that glue them together, discovery. And there are other kinds of transactions that we might want to enable on the network. And of course, blockchains are the ideal tool for doing this. And so the Wireline platform incorporates multiple side chains, most notably the Wireline naming service, which, as I mentioned earlier, is a permissionless blockchain. And then we also want to be able to build applications that interface with existing applications and businesses. And the ideal way to do that is to build a peer that is a bot that's under your control that can act as a gateway to the web to access services that users may want to continue to interact with. In fact, we think it's inevitable that the web is going to evolve into becoming a hybrid of different kinds of decentralized technologies, all working together. Now, what's important to us is to work with many different decentralized projects in order to realize the vision that we're trying to work towards. And some members of the engineering team are here this week. In fact, we'll be at the peer-to-peer hackerspace node next door for the rest of the week. So please come and talk to us. And thanks very much for taking a first look at Wireline. Thank you.